Welcome. Okay, so today, guys, we're just going to look at the graphing method to find the point at which two lines intersect, otherwise known as, of course, our simultaneous equations. We've done this already in class. Just thought I'd make this video so if you want to go back over it and have a look how to do it, it would help you, of course, when revising for either your tests or your exams. So I'm going to put two linear equations, so two functions. Up here. So one basically says that y is equal to whatever x is, add 4 to it. And this one here says y is equal to 2 lots of whatever x is, plus another 2 units. So if I make myself a table, x on top and y. Now I'm going to choose the values 1 and 2. Now the reason I chose them is because on my graph here, you can see that I want it to be reasonably short. Like if I chose 10, for instance, I'd have to draw a longer set of axes, and unfortunately I don't have that much paper. So I've chosen 1 and 2. So I'm saying here, when I look at this, that x's value is 1. Now, if x is 1, then y is equal to whatever x is, add another 4 to it. So 1 plus 4, y is going to be equal to 5. And this, of course, creates a point. Now, we can redraw this point down here, remembering, of course, that x always goes first, followed by y. And we have this point 1 dash 5. So on here, of course, it tells me to go across 1. So across 1. And then it tells me to go up 5. Okay, so let's do that. We'll go across 1, and then we'll go up 5. Now, of course, this would probably be a little bit easier on some graph paper and probably a little bit more accurate. And that's why this method is probably one of the least accurate of the 3 methods that we're going to show you in this series of videos. In this case, I've now made x equal to 2. So 2 plus 4 gives us 6. So I know that 2 across. So once again, this becomes a point. So 2 across, and of course 6 up. So let's do that. We'll go 2 across. We need to put the 6 up here. 2 across, 6 up, and we end up being here. I do know another thing about this function is that this last value is called, I'll just get on there, it's called the y-intercept. And that's a fancy name for telling us that this is where it cuts the y-axis. So I can put another point on there, or I could add it to my table by saying when x is 0, because remember we haven't moved side to side here, we've just moved up, and y is 4. Okay, so now I've got those 3 points. What I'm going to do is I'm just going to stick my ruler down, and we'll draw a line to them. And when you draw a line, don't forget, of course, to put your arrows on the end, because that line doesn't just stop there. It goes on to infinity and to negative infinity. So we've managed to graph one of these equations. So now, of course, what we're going to do is we're going to graph this one, and then hopefully we're going to see where they meet up on this set of axes, so we can do this simultaneous equation. So here we go. X, of course. Now the numbers I picked were 1 and 2. I'm going to put 0 in this time. 1 and 2. So if I make x equal to 0, I'm going to rewrite this because this actually says y is equal to 2 lots of whatever x is plus 2, just so that I realise that there's a times in between this 2 and this x. So if I make it 0, 2 times 0 is 0, plus 2, of course, gives us 2. So when x is 0, so we haven't gone side to side, but we have gone up 2. So we haven't gone side to side, but we have gone up 2. So the next thing we need to work out is what happens when I make this x equal to 1. Well, 2 times 1 is 2, plus 2 gives us the number 4. And of course, for the last one here, 2 times 2 is 4, plus 2 makes it 6. Now, I don't know if you've noticed something, but I have. I've noticed that this value and this value are the same. So, pardon me, if I draw a graph of this, so sorry, this one's 1 across and 4 up. So 1 across, and 4 up, so not quite there. But this one, which is 2 across and 6 up, we notice that both lines have that point in common. So we have actually, I tell you what, I need to go over a little bit more there. That wasn't a great X. If we draw these together, then they meet at, so X is 2. So that's the first thing that I put down. And then, of course, we go across to here to read off our Y value. That Y is 6. So we found the points at which these two lines meet. And we call this a point of intersection. So this here is known as a point of intersection. And in this particular case, it is 2-6. So we managed to find it using the graphical way. What are some of the problems with the graphical method? Well, number one is we need to have a graph. The other problem is, of course, is that if you have a look at my graph, now I've been incredibly accurate today. I've used a ruler, I've used all those different things. But if I actually got this ruler on 2 and lined it up, we're kind of off a little bit. And if we have a look at where 6 is exactly, you can see that I haven't been incredibly accurate. So while this is a method that you can use, it's probably not particularly as accurate as if we went down and started to look at a more algebraic approach to finding where these 2 points are. And that is going to be the topic of our next video. So just to share back what we did. So first off, we had to read the equation. We put in values for x. We chose these values. And then we used the equation to find out the values for y. So I chose 1 and 2 and 0 because they're very close, and so I didn't have to draw a big graph. We then graphed y is equal to 2x plus 2, and we noticed, and when we drew the graph, that they intersect at this particular point, which is x is 2 and y is 6. So that is one way of showing that you understand where the point of intersection is between 2 equations or 2 lines. And probably, you're dead right, I should have put these on, and I definitely should list what these equations are. So this is x plus 4, and y is equal to 2x plus 2. Thanks guys, I hope that was helpful. Yeah, and catch up in the next video when we do the elimination method. Bye-bye.